Trigonometry review. Okay, so what we're going to be doing is really just going over concepts learned in Math 30-1 trigonometry. We're going to be doing trig ratios, we're going to be doing graphing, solving trig equations, and simplifying and proving expressions using trig identities. All right, so all stuff you guys have done. So for calculus, we're going to be measuring all of our angles in radians. So you should be able to put your calculator into radians now and leave it there. You shouldn't have to be changing back and forth between radians and degrees. Okay, so trig ratios. So if you remember our trigonometric ratios, well, for like sine theta, would really be opposite over hypotenuse, right? And this is just that whole SOHCAHTOA thing, right, for sine theta. But really, in the context of calculus, instead of it being opposite over hypotenuse, really what I'd like to do is think about some point on the circle where the radius would be r, and then the x value and the y value, right, would relate to these two legs of the triangle. So this would be my x, and this would be my y, right, if this was point x, y. Okay, so instead of relating sine theta in terms of opposite and hypotenuse, what I'm going to do is actually call it y and r. Make it red. So y and r. Okay, and then cos theta, well, that would just be x over r. Tan theta would be y over x. Cosecant theta would be, well, that's the reciprocal of these two guys, right? So that's going, or sine theta, so that'd be r over y. Secant would be r over x. And then cotangent would be x over y. Okay, now if you remember back to, while we're at it, maybe we want to remind ourselves about this one. Y, right, can actually be called sine theta, right? If you remember way back. But that really is sine theta, is what our y is, and x really is cos theta. Okay, so this we can also call tan theta. Well, that would be sine theta over cos theta. And then cotan would be the inverse, or the reciprocal. So cos theta over sine theta. All right. Now, special triangles. Well, with our special, the reason why we're bringing these up, and these angles probably look familiar, right? These really are where we get our unit circle from, right? And the reason is because with these special triangles, we know what the lengths are. So if the if let's say the height here was 1, then this would have to be 2 and root 3. And then if we had this special triangle where the sides or the legs were 1, 1, and this would be root 2, then what we can do is say, well, okay, if we're at pi over 6 radians, or 30 degrees for reference, then let's say cos theta, cosine theta, for that angle, would be equal to root 3 over 2, right? And, well, what about sine theta? So sine theta would be y over r, so that'd be 1 over 2. Yeah, this is all looking really familiar, right? This really is our unit circle. Let's actually jump over to the unit circle for a second. So this is the idea, right? So if I've got pi over 6, right, or 30 degrees there, then I know what the points where the x value and the y value are here. Or, like you could also say, I know what the value of sine theta is, and I know what the value of cos theta is, right? So, yeah, I made this little applet where you can, it'll kind of show you that too, right? So the red arrow there is the value of cos theta, okay? And you can move that around. So right now we're just in quadrant 1. Yeah, and then sine theta would show you the y value there. Now, tan theta really is just sine theta over cos theta, right? So if you click that one, it kind of gives you the simplified version, right? Root 2 over 2 over root 2 over 2 would be tan theta is equal to 1. Now, while we're looking at this as well, let's maybe look at the angles a bit more closely so you guys can remember some of the patterns that show up to remember them. So what I did here is if you click on the angle sections, it kind of breaks it down a bit. So if you're on this one, right, this pi over 6, do you see how, well, pi would be over at, over on 180 degrees, right, over here. So this is 1/6 of that, right? And you can see the different sections of like the pie here, right? So this is 1, and then there'd be, the next one would be 2, 3, 4, 5, 6, right? Get you all the way around. And then you just keep on going. So those are like my 1/6 sections. So the reason why that's helpful is because you can see quite easily, right, when you're over here, what would this be? Well, if that's pi over 6, then that's after 5 of them, right? So that's just 5 pi over 6, right? Just counting the sections there. Okay, and then maybe what is this one? Well, that's going to be, this would be 6 pi over 6 to there, so this must be 7 pi over 6. So from here to here would be 7 pi over 6, right? So that's kind of the idea with those ones. You can kind of just get a visual of that. Now, move up to the next one. You can see these are in my quarters, right? So this is 1/4. 2/4 would be at 90 degrees there. And then you've got 3/4, right? 3/4, so 3 pi over 4. And then 5 pi over 4. So I'll let you guys kind of play around. This is on the website there. All right, so moving on from there, let's look at or remind ourselves about the cast rule, right? So the cast rule is really telling you where cos, sine, or tangent are going to be positive or negative, right? So if you remember the cast rule, it started in quadrant 4 and then to 1 and then like this, right? So this is cast. So this would mean that they're all positive in this quadrant, right? So then cos would be, let's say, positive here and here, right? There's actually 2 places that'd be the case. Sine would be positive here and here. Okay, and really all this is doing, like if you have a picture of the unit circle, you can figure that out as well, right? So if we think about this one, like maybe sine theta, right? So sine theta is the green arrow there. It's our y value. Well, yeah, it's going to be positive in quadrant 1, right? Because it's above the x-axis there in quadrant 1, but then it also will in quadrant 2. Right, so you can just kind of see that from, we don't really need the cast rule. We can kind of see from the unit circle. And then sine would be negative down here, right? Now we have negative values for that one. Same with cos, right? So now cos, well, that's going to be positive in quadrant 1 and then also in quadrant 4. And it's going to be negative in 2 and 3. Okay, and then tan, because I didn't need that on. So then tan, well, tan, yeah, it's going to be positive in quadrant 1 because they're both sine. Tan is really sine over cos, right? So the green one over the red one, and they're both positive there, right? So it's going to come out positive. And then it also would over here, right? Because they're both negative. So negative root 2 over 2 divided by negative root 2 over 2. Well, then that's positive, right? So that's where it would end up being positive again. All right, moving on. All right, so it says determine the exact value of each of the following. So it's tan of 11 pi over 6. So let's go back here again. So I'm going to turn on my angle sections. So 11 pi over 6, right? So it's really going to be this kind of a picture that I'm thinking of, right? And the over 6s are going to happen here, here, there, and there, right? That's where we're going to, be forced to make it over 6. Okay, so 11 pi over 6. Well, 12 pi over 6 would be 2 pi. So I really think it's going to be the one right before we're all the way around, right? So this is the angle we're looking at. So now tan of 11 pi over 6. Well, tan is sine over cos, or y over x. Okay, so negative 1 over 2 over root 3 over 2. So yeah, it's just going to be negative 1 over 2 divided by root 3 over 2. Now you can turn that into a multiplication statement by multiplying by the reciprocal, or if you're getting good at this, you might notice this would be the same thing as negative 1 over root 3. Okay, so that is true, but then we should probably rationalize that. So divide the top and bottom by root 3. So this is negative root 3 over 3. All right, cotan of negative 5 pi over 3. okay, let's think about this one. So negative 5 pi over 3. Let's figure out that one first, and then we'll figure out what we have to do with cotan. So negative 5 pi over 3. Now, sadly, I didn't make the ability to do negative angles, but if you remember, negative angles would just be going the other direction, right? So positive would be going around this way, and negative would just be going that way, right? So what it might be helpful to do, I find, so let's just forget about the negative for a second, right? So forget about the negative for a second. Forget what the number was. Negative 5 pi over 3. So let's just go 5 pi over 3, right? So our over 3s are this one, right? Pi over 3. So that'd be 1 pi over 3. This would be 2 pi over 3. Okay, and then 3 pi over 3 would be there. And then this would be 4 pi over 3. And then, yeah, 5 pi over 3 would be, you know, 5 of these triangles all the way around, right? So now, that would be the positive version, right? So it'd be, if it went all the way around, the positive angle. Well, we really want to do the other way around. So can you see, you know, we went from here all the way around to there? Well, we just go around the other direction. So that'd be like 1, 2, 3, 4, 5, right? So that's really where I am, right? That, if I did the negative direction, so that'd be starting here, that would be 5 pi over 3, right? That's what that angle is. And so why that's useful is because now, like, this is really what's important, is that we know that we landed here in the end, right? Now, what were we looking for? We're looking for cotan of that, right? So cotan of negative 5 pi over 3. Okay, well, cotan is just the inverse of tan, right? So tan would be sine over cos. So it would have been root 3 over 2 over a half, right? But cotan is cos over sine. So this is going to be 1/2 over root 3 over 2. So 1/2 over root 3 over 2. Okay, so it's kind of similar to last time, right? Just it'll be positive this time. So this would be 1 over 3, or sorry, root 3, which would simplify 2. So just rationalizing the denominator would be equal to positive root 3 over 3. All right, cosecant of 3 pi. All right, let's look at that one. So cosecant of 3 pi. Okay, so 3 pi, well, okay, 1 pi would be all the way around. 2 pi would be to there, and then 3 pi would be, again, right? Even though it just says pi, I'm actually at 3 pi there now, right? So cosecant, let's remind ourselves of what that is. So here, let's just get that picture in our mind that we're, you know, at -1, 0 at that point. So if we look back to the beginning here, really cosecant was r over y, right? So cosecant 3 pi, so r in this case on the unit circle is 1, and then our y value there was 0. Okay, so this is undefined. Now, another way of looking at this, you might think of it this way, right? Just going r over y, right? Just fine. That, because that, it really is just the reciprocal of those guys, right? So we can think of it that way. Or the other thing we could have done too, you could have said cosecant 3 pi is equal to 1 over sine theta, right? And then sine theta is equal to 0. So that's still equal to 1 over 0. But I just want you to be ready if you see it that way, right? They mean the same thing. Okay, next one. Sine squared of 3 pi over 4 plus cos 4 pi over 3. So now this squared, right off the bat, I just want to remind you that that actually means the same thing as sine of 3 pi over 4 squared, right? Like the whole thing squared. It means the same thing. We just do this for short. Okay, so it's really that plus, and then I'll just write this again, cos 4 pi over 3. All right, so really we just need to figure out what sine 3 pi over 4 is and what cos 4 pi over 3 is. So sine 3 pi over 4 Let's maybe do it one more time on here. So sine, so 3 pi over 4 would be there. We need that one on. So remember what sine is. Sine is really just our y value. So it's root 2 over 2, right? So just right there, right? That's what sine is. Okay, so this is going to be root 2 over 2 squared plus, and then cos 4 pi over 3. So 4 pi over 3. So remember our pi over 3s were, this spot, right? So this would be like over 3. So we got 1 pi over 3, 2 pi over 3, 3 pi over 3, 4 pi over 3. I said that, but didn't actually do it. There we go, 4 pi over 3. Okay, so then it's the cos value, right? So like our x value, so that's negative 1/2. And then just simplify. So this would be 2 over 4 minus 1/2. And this is really 1/2 minus 1/2. So this is 0. Okay, so now graphs of basic trig functions. What I'm going to do, let's go to this one. So let's start with, what do I have there? Sine first? Yeah, so let's do sine first. I'm going to turn on my special angles and go in radians. Okay, so actually I won't do that yet. So what we can see for sine, right? So sine, remember what sine is. Sine is the height of that point all the way around the circle. So look at my graph down here, right? So my graph corresponds to this height. So as I'm moving this around, so it starts at 0, right? No height. Comes up, then it has full height, right? It's at 1. And then comes down, it has no height. And then it has -1. And then around. And it just goes around and around, right? You could do the same thing going in the negative direction if you like, going around. Now, if we switch it up, we can think of it in terms of cos, right? So cos is the blue, right? This is our x value. So it starts out at 1. Do you see how it starts in a different position? Well, it starts at 1 because it's at full length here. It's at, in a unit circle, it has 1 full unit right there. So it starts up there. And then as it goes around, my x value shrinks down to 0. And now it has -1. And then 0, and then +1, okay? So the same thing, but the whole thing has just been shifted, okay? So a cos graph and a sine graph look exactly the same, but it's been shifted by, well, 90 degrees, or pi over 2. And now quickly, let's just look at tan, right? So tan, see if this makes sense. So we've got our green arrow divided by the blue arrow, right? It's our y divided by our x. So what's happening here? Well, as we go up, right? Why does this thing start approaching infinity at the top? Well, the reason is because I'm dividing by a smaller and smaller and smaller number, right? Like right here, what if I divided by like 0.00000000001? That's a really big number. That's why I'm approaching this. That's why there's an asymptote there, right? I'm approaching infinity at that point. And then, yeah, this point doesn't exist. That is not in the domain, okay? And then as you go around, well, now I've got positive value, positive green arrow or y value, divided by a tiny, tiny, tiny little negative value. That's why it's down here now, right? I'm into the negative territory. And then you come around, and then right here, well, this is, my green arrow is 0 divided by 1. Well, that's just 0, so that's fine. That's just on the x-axis. And then coming around, we run into the same problem. Well, now we've got negative green divided by negative blue, which is positive, but then 1 divided by an ever smaller number there starts to approach infinity. And then we get that pattern, right? So yeah, let's jump back to the graph. Let's make our own now. So sine theta would start at 0, and then let's make it, like that. Yeah. Okay, and then we'll do the same in the other direction there. All right, and then let's do cos. So then cos, same thing, but it's starting at 1 on the y-axis there. And then there, there, and there. And then let's do the same for the negative. All right. Now notice the period of this graph is 2 pi. So from here to here, right, where it starts repeating is going to be 2 pi, right? So that would be pi there. That would have been pi over 2. This would have been 3 pi over 2, and then this would have been 2 pi right there. Okay. Now, same with cos, right? So cos, the pattern repeats. It starts here, and then it starts repeating again there. And you can find that pattern anywhere you like, right? You could go from here to here. That would also be 2 pi in that section. So yeah. Now tan's a little bit weird, right? Tan started, at 0, and then I'm going to make my scale. Let's make right here pi, right? Which would make this negative pi. Right? Now, really, pi over 2, I'll make that right down the middle of that. So we can make an asymptote. And there would be one there and there. Okay. Well, the way this worked, right, is it went up, started approaching infinity, and then from the negative started coming up here again, and then passed through pi again. And then we would have another asymptote here. So then it would go up here. Now, let's fill in the back side, right? We've got this kind of a pattern happening. We'll make this asymptote over here. And so on. Okay. Okay, moving on. Now, this one wasn't really reviewed from Math 30-1. We actually have just talked about symmetry in earlier calculus lessons, right? But let's apply this now to our graphs of sine, cos, and tan, right? So an even function is a function where f of negative x is equal to f of x, okay? And the functions are symmetric about the y-axis. So if you've got your axis, right, so an example of this would be something like this. If I could draw better, right, that would be symmetric about the y-axis. An odd function is where f of x is equal to negative f of x. And that would be an example, maybe something like this, right, where it's kind of reflected or rotated almost around the origin. So let's just quickly look at how that relates to the graph of sine x. So sine x, this one, right? Do you see that, up here is symmetric about the origin, right? So this one is odd. Okay, cos is a little bit easier to see, right? You could flip that thing right over the y-axis and it would look exactly the same, right? So that's even. And then tangent, well, tangent is similar to sine, right? Where this is going to be similar, or it's going to be, it's going to be symmetric about the origin again, right? So like this point up here, you can think about it as being down there now, right? It has that symmetry going across. All right, so that's going to be odd as well. So if sine really is odd, then what we can say here is that sine negative x is equal to negative sine x. And for cos of negative x is equal to just cos x, right? It's the same either way. And then tan of negative x is equal to negative tan x. All right, so find the symmetry of the functions. So, all right, so for find the symmetry, we want to input f of negative x. All right, so what that really means is we're going to put negative x in for all y-axis. So that would be sine of negative x over, and then cos squared of negative x. And you know what? Just so I don't confuse myself, let's write cos squared like that. All right. So now, using our rules from above there, sine negative x is really negative sine x. And cos of negative x is really just cos. So that I can just rewrite that now as cos x squared. And then from there I can see, well, this is just sine x over cos squared x, right? They look exactly the same, but I've just got the negative tacked on the front. This is really negative f of x. Okay, so what does that mean? That means this is odd symmetry. Okay, let's do it for the next one. So f of negative x is equal to, so this would be 3 tan, and then I'm going to throw in negative x, and then sine negative x. So that would be 3, and then tan negative x would be negative tan x. Just from my rules above, right? And then sine would be negative sine x. And then those two negatives would really cancel each other out, so we get 3 tan x sine x. So this is, which is equal to f of x. So this is even.